Welcome to the 1.2 video, the second one. In the previous video, we talked about dot plots and comparing distribution and describing them. In this case, we're going to do the same thing, but instead of with dot plots, I'm going to teach you a stem and leaf plot and a histogram. So here is some information from a stats class. Ms. Barbero has information about the number of shoes, number of pairs of shoes that her male students own. So here's the stem plot, the original stem plot, where 0 is the stem, and then these numbers here are the leaves. Each of these numbers represent one of the students and the number of pairs of shoes they have. So the first stem is going to go from 0 to 9. So you can see 0, 4 is going to represent this student right here who has 4 pairs of shoes. But this 2, 2 is going to represent the student who has 22 pairs of shoes. And you can see that student is right here. So since this data is kind of jumbled, there are a lot of numbers on 0, a lot of numbers on 1. One thing you could do is split the stems. So instead of going from 0 to 9 like we are here, you can go over here, and the first stem is going to go from 0 to 4, which is a total of 5 numbers. Then the next stem is going to go from 4 to 9, which is also 5 numbers. So it's going to cut them in half. That way, this one is going to represent 10 to 14, and this second one is going to represent people who have shoes from 15 to 19 pairs of shoes. So this is what we call a split stem, and that is just to give you a better view of what the data looks like. Now, when you're making a stem and leaf plot, it's very important to notice that you must make a key. You have to say what this 2 and the line 2 represents. It's a male with 22 pairs of shoes. So with making a stem plot, you also need to be able to describe the shape of the distribution. So when working with quantitative data, just like a dot plot, you need to think always in terms of a number line. So you can see if you flip it on as a number line horizontally, it's going to be counting from smaller to larger numbers. So in this case, you can see that it's unimodal, but there is a tail being stretched out towards these higher numbers, which on a number line would be to the right. So that's how we will know that this distribution is skewed right. So the key is to think about the smaller numbers and it's stretching out to the larger numbers, just like a number line is from left to right. Just a quick note about stem and leaf plots. If we're working with like GPAs where it's a decimal, 3.2 or 3.4 or 1.3, then you can use the number as the stem and the decimal would be the leaves. So I want to take a look at another stem plot or a stem and leaf plot from data that I collected last year. I have the females in my class heights and the males in my class heights. So I'm going to go ahead and I'm going to make a stem and leaf plot for the males. And then I'm going to pause and I'm going to tell you how to make what's called a back-to-back stem and leaf plot. And for the males, I can already see that there's going to be, it's only going from 150 to 180. So I'm going to create split stems for this, so it'll give us a better view of the data. So there I've completed the males stem plot. I split the stems, like I said. So the first stem goes from 150 to 154. The next stem will go from 155 to 159. And the same with each of these. They're just split up into 2 equal widths of 5 numbers. So now I'm going to make the female distribution. I'm going to put it over here on this left side, and it's going to be a back-to-back split stem leaf. So this is called a back-to-back stem and leaf plot because obviously they're back-to-back. Important things to make a note of is the first numbers all need to line up on each side, because if all 4 of these numbers were crammed in and they were the same width out as this 3, it would be misleading about the shape of the male's distribution. So now what I'm going to do is I'm going to compare these distributions using SOCs, which we've learned before. So I'll write those out and then we'll discuss it. So one thing I forgot to mention was the importance of having your key. So I added in the key there. You will always need to have a key if you have a stem plot. And I've described the shape, outliers, centers, and spread and compared them. The females' heights are symmetric, as you can see here, 4 below, 4 above, this peak in the middle. The male's distribution is skewed to the left, so you've got to imagine this flipped on a number line, the lower numbers to the left, the tail is stretching out towards these lower numbers, which would be skewness to the left. The male's distribution appears to have one low outlier at 152. The females don't appear to have any outliers. Compare their centers, make sure you're using the right words here for describing. Typically, the males are taller, and use your evidence. The center is at 176 versus 163. Another buzzword when comparing spread is that the males' heights vary more because their range is 31 versus the female's range, which is only 21. So for the last thing I want to show you is how to make a histogram. And this picture right here is a great way to think about what a histogram is. It's like a dot plot, but instead of showing each individual value, now it's going to put them in a bin or a class. So from 0 to 5, how many are there? And it totals them up. So this is what the histogram will end up looking like. It just shows the total number of values between the certain range. So I am going to make a histogram for the male's heights. The first thing that we need to do when we are making a histogram is figure out what size bins or what class size do I want. Like from here, it was from 0 to 5. So since my male's height goes from 152 to 183, I'm going to count by 5s because that will give me approximately 6 classes or 6 total bars. So when you're making a histogram, you want to have at least 5 bars like this. So first, I'm going to create my bins, and I'm going to count up how many fall in each, and then I'm going to draw out my histogram. So first, you can see I made my bins that are all of size 5. It is important to note that your bins are equal in width. So I need to count from 150, 151, 52, 53, 54. That's a total of 5. So I'm not including 155. That will be included in the next bin. So it's really important that they are all the same width. After I've made the bin sizes, all I did was total up how many fall in the first bin. And you can see from the data set, there's only one male who had between 150 and 154. So from here, I'm going to draw my graph and create the bar for each bin to show the frequency. And so there would be my histogram showing the distribution. A couple of errors that I see students make all of the time. Instead of counting their x-axis like a number line, like it should be from 150, 155, a lot of times I see students want to make it a bin where they're saying this is from 150 to 154, and this is not correct. That would be for if it was a categorical distribution, but this is quantitative, so it needs to be counting and showing gaps in the data. Histograms are different than bar graphs because gaps make a difference. It means there is no data falling from 155 to 165. So that's an important thing to make a note of. I see a lot of students incorrectly labeling their x-axis on a histogram. So in this case, we would describe this distribution. It looks like it is skewed to the left because you can see this tail being stretched out to the left and is unimodal. And we can count and find where the center is. But that's how to make a histogram.